Now we will be doing the question of merge k sorted list. It is, I think, an improved version of merging two lists. Okay, so yeah, it is the improved version of merging two lists. So we have been given k sorted lists, and we need to merge this k sorted lists. So I think the approach will be similar, but now what we actually want is, first of all, we want to find out the length of this list, right? Let us name the, okay, let it be list. So yeah, so this n denotes the length of the vector. So we have, so what we want is we want to merge all this into a single list, right? So let us say this denotes our new list. So let's say let's use use variables which we were using previously. So in previously we were comparing between two of them, right? That's why it was quite easy with the if else statements, right? But now what we will do is we will create a priority queue, right? So we will create a priority queue, and the priority queue should contain two things, right? So the first thing that it should contain is the pointer of the first indices of each and every list node. Secondly, it should also contain the index. So basically, if I want to pop the minimum one, then I will pop the minimum one and I will. So is there any way that we only store the tree nodes? Let us say we only store the tree nodes, but we do not. Okay, so let us say we only store the tree node, and because if we are storing the first indices of every tree node, then I think we are good to go with the tree nodes itself, and we do not want to mm, further, because the pointer which we are popping out will itself be the pointer of v of I of some node, right? So we can obviously do make it next. So yeah, I think we will be so yeah, we will be using this. So let us say we are creating a min hip over here, and I think this is the right syntax to create the min hip. Okay, if we will be getting a syntax error, so let us specifically mention that this is a min hip, and let us say for int I equal to 0, I less than n, I plus plus. So what I will do is I will just lists of I. So what I will do is, so this is the min hip that I have. So min hip, I will just push this node which is currently a list of I into the min hip, right? So I have pushed this into the min hip, and now once I've pushed this into the min hip, I am good to go with the while loop. So what I will do is I will so let us say while this min hip is does not become empty, so the while not of min hip. So while this min hip does not become empty, I will constantly try to let's say this is RT, which is the root node. I will constantly try to pop this out. So once I have popped the top of the min hip, now what I want is, okay, so for the first thing, what I want to do is I want to initialize this min hip, right? So for the initialization step, what I will do is I will make nd. So no, basically, yes. So let us do this over here. I need to pop this element out. Let's say I want to make this element over here, and I want to make minhip dot. Okay, if art is next exists, then only I want to push it to the minhip. right? So yeah, I will push this into the minhib, but the thing is, so how will this list nodes be sorted in the priority queue, right? So the priority queue needs to know that it needs to sort this linked list in a way that only uses uh, the values to compare between two entries of the linked list. So I think over here, I think we need to write our own comparator. So I have not done this before. So let us say we make this as the comparator. So I don't know how this is done, and but I know the trivial solution, that is to construct a Boole's comparator, and I don't know if this will work over here. So this is a new thing for me, because let us say this is the node A and this is the node B, and we want to compare both of these nodes, right? So if the value of the first node is less than the value at the second node, then we will return true, return 1, which is true, but return, okay, so I think there is no need to return this. We can simply return this. Since it is a min head, we want this to happen. So I don't know if this would work or not, but if this won't work, then we will quickly go onto the web and search for the custom comparators to priority queue, right? So because there might be cases wherein we need to construct some kind of structure and then push it in there. But okay, so for now, let us not worry about it, and right now focus more on creating the code, right? So let us say we have this and we have this node, we pushed this into the node, and right, we are good to go now. And now what we did is we did something similar, but instead of this, what we now did, okay, so also when once this is initialized, I also need to initialize it with TP, which is the top, which we are going to return. So, yeah. So if this is the case, if art is not exists in this, so I think this is fairly clear now. If the custom comparator is working fine, then it should return the TP perfectly, right? So let us try and run this code. If this does not work, means our comparator is not working properly. Cannot return function type bool. Okay, so let us quickly go to the web and write custom comparator priority QC++. Okay, so they are expecting us the structure, right? So the structure can have arbitrary name, right? Okay, so what we can do is we can create a structure outside of the class. Let's say we have this structure which is saying compare, right? So it is saying compare, and it should have this operator inside it. So this should have the semicolon, and it should have this operator inside it. And when we are using this compare to compare our nodes, I think, is this working now? So there is an error over here as well. Okay, so what are these P1, P2? These are the pointers to the node. And while declaring, I think vector of person. Okay, I think over here it should be, this word is wrong, it should be operator. So now what I'm getting is output as 2 and 4, but in the very first case, why? Because this 112 we are getting 2, but why? Because firstly we are getting 1 and then we are getting 6, but let me check out. So initially we pushed out the pointer, then I'm not sure why it's giving me this answer. Okay, because I'm not getting Trevor, so Andy should be equal to Andy of next. I think this, that is the error, that I am also not propagating my Andy with the output, right? So 261. So I now look at least I have the length as the same, but I think there is something vague with the comparator going on. So I don't know, but it should swap if A of value is greater than B of value, exactly. Then we will get the sorting, right? Why? Because um, we want the minimum to be at the top, right? If we want the minimum to be at the top, then we want the swapping to happen if the value is greater. So I think this should work fine. Okay, in the case list can be empty. So if n is less, if n is equal to 0, then you can return null. So this is special cases we need to take care in the interviews as well. Now we need to look at the constraints which are given. Now what is this? Okay, so it is saying if each and every pointer is a null pointer. So what we are expecting is, so over here ND will become null. So if RT, okay. So actually I do not want to push out if it is a null pointer. So let's say if list, I want to push them only if it is not null. So what I will do is I will instead say list of I. If this exists, then only I want to push them. Otherwise, I do not want to push them. So if there are null pointers, I am not interested in the null pointers. So I think that should work fine now. If there are no more errors, the error persists for the same. So let us try to copy it and see what the result they are expecting from my side for this input. The output should be a null pointer, and I think TP is a null pointer if it is not initialized properly. Is it giving a, okay, it is giving a runtime error. Why? Because The size is, so it's like we have one pointer in the bucket, but it is a null pointer. So let us say that our heap remains empty, right? So if the heap is empty, then also we need to return null, right? So if there is nothing that we can push into the heap, then also we need to return. So there might be seven possible vectors, each having a null pointer. So what we can do is we won't push any of them, and then we are extracting the top, so that is giving a runtime, and so finally we succeeded. And so basically, I think there are various approaches to this question, but in the approach which we did, we always made sure that the size of our min head at any given time will be nothing but equal to the size of the vector, right? So if there are k linked lists, then our size of the min head won't exceed k, right? And also we are not, we are just storing the pointer to the node. I think this is the good approach. So let us compare our solution with the solution. So I want to talk about the brute force approach. Hmm. Compare one by one, priority to this is I think what we have done. Merge lists one by one, merge with divide and conquer. Let us look at the space. So what will be the time complexity in our case? So in our case it would be linear, right? Of k into n. Now that would be our time complexity as well. But I think they have something good with the divide and conquer approach. So let me think of something with. So let me think of my. So I think my first problem was this one, right? So I did this approach. Why? Because okay, so there is a cost for pushing into the minhib, so that is a log n cost. So over here we are doing n log uh, k cost basically. Why? Because this push will be operated on k times if we assume that there are k linked lists, then and n log k would be the approach for my time complexity for my approach. Right. So even in case of divide and conquer, they're getting analog k. But the space complexity that they're using is O of 1. Space complexity that they are using is O of 1. So I think this approach is fairly clear by now. So this was a new thing that we can create a custom comparator. We need to create a struct for this. Let us try to run this without using a struct. I think it won't work now. Then, or maybe it would. Let me try. I think it should not work because if it is defined under the structure, then only it should work, right? Yes. So it won't work. Let me know in the comment section if there is any better way to do this, right? So let us now move forward to the divide and conquer approach, which is using O of one space. So I will just erase this solution. Or what I can do is I can reset to default parameters. So we have reset it to the default parameters, but we can always undo it. So yeah, we can now define. Yeah, we have. Okay, so let us try to do this with merge with divide and conquer, right? So what we can do is now they want us to solve this using the concept of divide and conquer, right? So what we will be dividing, that is the question first. So will we be dividing the range? So let us solve it for the k by 2 part first and the less k by 2 and assume that both of them are sorted, and then we can use the approach of merging two sorted lists, and that would be costing us O of one space complexity. Then okay, so I think that is the only approach that they're trying to do is Yeah, divide and conquer is like sorting. It's like sorting using merge sort, right? So we know that all the lists are individually sorted. So what we will do is, so first of all, we will try to sort out. So I think, let me read it. This approach walks alongside the one above, but it is improved a lot. We don't need to traverse most nodes many times repeatedly. Pair up k-lists and merge each pair. After the first pairing, k-lists are merged into k by 2 lists with average 2 and by k lengths, then k by 4, and by k by this is read this as n divided by k by 2, and so on. Repeat this procedure until we get the final sorted linked list. So let us say this is the initial list which we have. So first of all, we will we will do this, we will do this, we will do this, and then okay. So what they want us to do, first of all, write a separate function that merges two linked lists. And once we have written that separate function which merges two linked lists, what we want to do is, so let us create another vector. So they are using a constant space to do this. So this is in Python. So let us say this gives us the length of the linked list. Okay. So they are using a kind of tree-like structure. So basically, currently, let's say if the length is one, so let us say this is one based indexing. So we will merge one and two, then we'll merge three and four, then we'll merge five and six, right? And at any point, after every point, what we will do is we will take the ceiling of the length, right? So I think after that step, I think list of zero will contain the merge answers, list of two will contain the merge answers, and list of four will contain the merge answers. Then after we are done, then list zero should be merged with list two. So how we are tackling with this amount is the length and interval. Okay, so initially interval is one. So once we are done with the interval of one, so let us say this is zero based indexing, so which they have done in the diagram as well. So if it is a zero-based indexing, then first of all it is list zero, interval is one, so they have multiplied it with two. So now they will increment zero with one into two, which is two. So it will go from zero to two, then it will go from two to four, and it will merge with the neighbor. Then after that, the interval is multiplied with 2. Why? Because we have skipped 1, 3. We don't need 1, 3, and 5 in this case. So we multiplied it with 2. Why? Because now we want to merge 0 with 2 and merge 2 with 4, and then we will merge this out, and this will be multiplied by 2 again. So over here interval value will become 4, and we will merge these two, and then we will get result, right? So this is a good approach which uses constant space. I won't be implementing it. Maybe I will create a separate video for implementing it, or maybe I should implement it. I don't know. So let me check if I have this merge to sorted list. I can use this function to if this function. Yes, what I will do is I will implement it, but I will use my this function to implement it, right? So I won't write everything again from the scratch. But yeah, so let us copy this function's name. Let us say that we have this function's name, right? So initially, let us say that int n denotes the length of the this. So initially, let's say this int n denotes the length of the linked list, that we the length of the vector. So let us say not confuse us, not, let us not confuse, and let's say this is k because we have been given k list, right? So now we need to do it using divide and conquer, right? So let us say that initially we are having an interval of length. From 0 we need to go to 2, right? So let us say this is 1. Why? Because we will skip one node. So interval denotes how many skips we need to make, right? So now let us say, or maybe for int I equal to 0, I less than n, k, I plus equal to interval into 2, right? Right? So from 0 it will go to 2, then it will go to 4, right? And then what we can do is list of I is nothing but, let us call this function on list of I and list of I plus. Now I cannot do simply I plus 1. Instead what I will do is I plus 2 into interval minus 1. Let's say the interval, so we are doing with 0, right? So this, I think they have done it in the similar way, I and I plus interval, right? Cool. Why? Because we know that first of all interval is 1, so we have skips of 1, and after everything is done, what we can do is interval is equal to 2 into interval. Why? Because initially we were skipping 2 nodes, now 1 node, now we will be skipping 2 nodes, right? So let us say initially we were skipping this 1, 3 and 5, right? We were going from 0 to 2. Now we will skip this 1, so we will skip this 2, 1, 2 and 3. We will skip this 3 and we will go from list 0 to list 4. Why? Because list 0 will now be paired with list 2. So at every moment of time, suppose we started with a skip of 1, then we will skip, um, we will move in, so we will take steps into powers of 2. First of all 1, then 2, then 4, right? So next is, so 1, so we will make a skip of 2 after this, after the first step. Then we will make a skip of 4. Right. So I think with the diagram, if you will think, then it would be pretty easy for you to make make note this. So what I want to make sure is this skips, whatever skips we are making, it should ultimately be less than the length, right? That should be the condition inside the value. So obviously our answer will be stored in list of 0. That is no doubt. So this interval should be less than the n, which is the length, right? This can be the condition for the value. So we will compute it. So then we can return list of 0. Okay, so I haven't defined. Okay, so this is k. There is a one-time error. Let me check. We want to merge these two linked lists, right, using the divide and conquer approach. I think I think this is the error which we are getting. For this, what will happen is we have these three lists. So list 0 would try to combine with list 2, right? So list 0 will try to combine with list 1. So what will happen over here is the k is 3, interval is currently 1. So list 0 will try to combine with list 1 because interval is of length 1 currently, and then list 1, then the I will become equal to I plus equal to 2. I will equal to 2, right? So what will happen is I should always be less than k minus 1 because if we are at the last index, then we are never. So yeah, what I should be actually less than equal to k minus interval. Why? Because I plus interval should be less than k, right? So I think now we are cool, ready to submit it. Okay, so yeah, there is again this thing. If k is 0, then we need to return null. Here again forward this statement. Yeah. So now our solution is quite faster. As you can see that the solution memory it is using is somewhat same, but this memory is of uh, calling to this function, else it is using O of 1 space. So I think this is all from my side. If you have any more approach to this question,